Next time we talk about greedy best first search, as in it is a very different type of algorithm than the last we saw. The last time we saw were deep first and breadth first that allow us to make an uninformed decision, meaning we don't know nothing about the puzzle and we only know what's in front of us or our frontier. But now we are making a more informed assumption of where our goal might be. And last time we looked at again greedy best search and how it failed to find the optimal solution. We find this solution. Sorry, this is the optimal solution, but we find this solution because our heuristic function, which is the little numbers here. Again, if you want to understand what's happening here, I definitely recommend you watch the last video. It will make much more sense when you do. What is the heuristic function? What is an informed assumption? What are uninformed assumptions? You can watch the last videos to find this out. But again, we have this solution far from the optimal. This is the optimal. This is what we got. So is there a way we can per se upgrade or greedy best first solution? Oh yes, this is called actually, or greedy best first solution was the last one, sorry. And what we want to do is that we want to add more math, which we do by using the A star search, a search algorithm that expands the lowest node with the value of G, N, and Hn, or the cost to which to go and the estimated cost to which to go, meaning the number of actions I took to get there and the number of actions I will probably need to get to the goal. So let's use with now this a better solution, this better a search algorithm or same puzzle or path to B pretty much. How are you going to choose where to go? Again, let's have the heuristic numbers. That's how the heuristic values of each tile I can walk in. After all, that's how you're going to make the assumption. But now is where it becomes interesting. Every time I take a step, the artificial intelligence will count it. So again, last time we did this because we aren't counting how many steps. We can of course see there are many more steps to get from, well, from here into this path that it costs us to go to the other way around. So now we begin tracking. I walk one path and I say that it's 1 plus 16, meaning 16 for the heuristic value from 16 tiles away, and it took us one action there, meaning it is 17, and we'll keep going this until we hit here. Now here's a very interesting point, because just like the really best first search, it will fall into a trap, because again it is the lowest number and it's lowest by 2, so it's not like an arbitrary decision here. It would be the same, and it will still fail. It will still go closer and closer and closer in the heuristic value until it hits a certain point where it stops growing, where the decision between 6 and that meaning 15 plus 6 and 6 plus 13 seems arbitrary. You could choose either. In this case, I made sure my artificial intelligence chose between 16 plus 6 and 6 plus 13. Again, it could go either way. In this case, for I would say you go to the best possible solution, and because of its number, it will slowly rise, and that is an interesting part actually, because it will rise here, and then it will hit a sudden stop of growth because every step I take will add the number, but it will also be a number lower because of the arithmetic function. So it will slowly make its way to B, to my goal B. And that's very interesting because it did fail. It was not perfect. It failed here. But it then saw its mistake. It saw that the cost of going this path is higher than the path of going this path. So, well, it made an informed assumption, pretty much, meaning it made its job. But is it the most optimal solution? Just like last times we explored, is this the best search algorithm we can have? Kind of. In these specific situations, meaning if the age is admissible, meaning which never overestimates the true cost, and is the g value, the cost, sorry, I mean the heuristic value is never overestimated. It can even be underestimated, but never overestimated. And the number of paths, the number of steps we need to go to one place is consistent with this little calculus, which pretty much meaning is between A and B pretty much. So I have two nodes here. And between these two nodes, they need to be in there like this. They are close to each other. The distance will always be 1. It won't be like a distance of 2 or more between each one. So meaning here meaning the successor, sorry, the successor of one node, like for example this is successor, and between this node and this node, the successor will always be lower or equal to, as you can see here, will be lower or equal to successor. So meaning, well, it always takes the right path. It will never take a path that is from successor that is higher than the other path. So pretty much meaning it could get stuck in a situation, a very specific. I would say it wouldn't even get stuck. It would just get stuck if we are, for example, if actually between these points, if we have these 2 points, it will never get stuck and we will always find the optimal solution. But believe it or not, not always happens. This is not always true. It's not always that it can estimate the true cost, and it's not ever that we can the best solution, or sorry, the worst solution. Sometimes the best. And how we know this? Well, we can do something like that with a game. A game where you have an adversary of artificial intelligence, and or is the artificial intelligence the adversary, or the adversary, uh, yeah, between artificial intelligence trying to solve a game puzzle. And so we reach the end of this video. If you did like it and you want to see how artificial intelligence will try to, well, pretty much play tic-tac-toe, then you definitely must subscribe and hit the notification bell so you will receive a notification when this video comes out. Not just that, but like this video if you did like it, and comment down below anything really about artificial intelligence. If you think that perhaps is a best solution, or maybe somewhere that the A star solution is not better than, for example, breadth first, the deepest, or sorry, the depth first, or really maybe a comparison, or just questions anyway. So again, Hope you like it, and if you want to understand everything that happens here, again, watch the last videos. And not just that, but if you want to access the course I am using, I'm pretty sure you can you can still enroll to the course. So just go to the description. I have the link there. And well, happy studies. And that ends for today. Hope you like it and see you tomorrow. Bye!